Hello friend, welcome to Science for Sleep. Whether you are coming back tonight or just discovering this channel for the first time, this is a calm place to slow down, learn something gentle, and let the noise of the day slowly fade into the background. Tonight, we are going to follow the quiet science of summer. Not just summer as a date on the calendar, not just the hot months between spring and fall, but summer as a feeling. The kind of feeling that can arrive before you even think about it. You step outside in the evening, and the air is still warm. The sky is not fully dark yet, even though dinner is over. A lawnmower is humming somewhere down the street. A screen door closes. A sprinkler clicks across a patch of grass. The smell of sunscreen, warm pavement, cut grass, lake water, or barbecue smoke can make the whole season feel as if it has suddenly returned at once. For many people, summer carries a special kind of happiness. It can feel like rest. It can feel like freedom. It can feel like childhood, vacation, beach towels, cold drinks, open windows, bare feet, and extra time. And that is part of what makes summer interesting. Because the feeling seems simple. Warm weather feels good. Long days feel good. Time off feels good. But underneath that simple feeling, many different systems are working together. Earth is tilted in space. Sunlight reaches the ground at a stronger angle. Days stretch longer. The body receives more light through the eyes. The skin feels warmth directly. Plants grow faster. Insects become louder. Water becomes a place to cool down. Food tastes different outside. Smells become stronger in warm air. And the human mind begins linking all of it to memory. If you enjoy calm journeys through science, nature, and the hidden details of the world around us, take a moment to like the video and subscribe. It helps this channel reach more curious viewers who want to learn slowly, quietly, and peacefully. Now, let's continue. Summer is not only one thing happening. It is a stack of signals. Light, heat, smell, sound, water, food, time, memory. A warm evening can carry all of those signals at once. That is why a single summer moment can feel so full. A beach is not only sand and water. It is sunlight reflecting from the surface of the waves. It is the body cooling in the water faster than it cools in air. It is the sound of small waves repeating again and again. It is the wide open view of the horizon. It is the smell of salt, sunscreen, towels, and warm skin. A backyard barbecue is not only food. It is smoke from wood or charcoal. It is the browning of meat, corn, bread, or vegetables over heat. It is people standing outside because the air finally allows them to. It is the sound of chairs on a deck, ice in a glass, and voices carrying farther in the open air. Even a quiet summer night has its own science. Crickets chirp faster when the temperature rises because their bodies are controlled by the warmth around them. Fireflies glow through a chemical reaction inside their bodies. Leaves keep making sugars from sunlight during the long, bright days. Warm air can hold more water vapor, which helps build the heavy clouds that sometimes turn into evening thunderstorms. So the happiness of summer is not only in the imagination. It is tied to real changes in light, air, living things. weather, and routine. But summer also becomes personal. A certain smell can bring back a cottage dock. A certain sunset can bring back a family trip. A certain warm night can feel like being a child again. When the school year was over, and the next morning did not feel so urgent. That is why summer can seem larger than other seasons. It touches the body first, then it touches memory. And before it becomes beaches, vacations, storms, fruit, flowers, and late golden evenings, it begins with something far above all of us. A quiet angle in space, a small tilt of the earth, and sunlight arriving in a different way. The story begins with the way Earth leans as it travels around the sun. Earth does not spin straight up and down. Its axis is tilted by about 23.4 degrees. That axis is the imaginary line running from the North Pole to the South Pole, passing through the center of the planet. Every day, Earth spins around that line once, giving us day and night. Every year, Earth also travels around the sun, completing one orbit in about 365.25 days. As Earth moves through that orbit, its tilted axis keeps pointing in nearly the same direction in space. That steady lean is what creates the seasons. In the Northern Hemisphere, summer reaches its peak around the June solstice, usually on June 20th or June 21st. Around that time, the North Pole is leaning toward the sun. Places like Canada, the northern United States, Europe, and much of Asia spend more hours turned toward sunlight. Farther north, the effect becomes even more dramatic. Near the Arctic Circle, around 66.5 degrees north latitude, the sun can stay above the horizon for a full 24 hours near the solstice. In places like northern Norway, northern Alaska, and parts of Arctic Canada, summer light can last through the night. The sky may dim, but it does not fully settle into ordinary darkness. Farther south, the change is gentler, but still powerful. A city like Toronto can have more than 15 hours of daylight near the June solstice. Miami, farther south, has closer to 13.5 hours. The exact number changes with latitude, but the pattern is the same. The hemisphere leaning toward the sun gets longer days. It also receives sunlight at a higher angle. That part matters. When the sun is low in the sky, its light spreads across a larger patch of ground. The same energy is stretched out more thinly. When the sun is higher overhead, the light lands more directly. The energy is concentrated into a smaller area, so the ground, water, roads, trees, and buildings absorb more warmth. This is why noon sunlight in summer can feel so strong compared with pale winter light. The sun is not simply staying up longer. Its rays are arriving more directly. A common mistake is to think summer happens because Earth moves closer to the sun. The actual orbit tells a different story. Earth reaches aphelion in early July. Aphelion means the point in Earth's orbit when it is farthest from the sun. At that time, Earth is about 152 million kilometers from the sun. In early January, Earth reaches perihelion, its closest point, at about 147 million kilometers. So in the Northern Hemisphere, the warmest season happens when Earth is actually a little farther away. The distance changes, but the tilt matters much more for the seasons. That small lean of 23.4 degrees changes the length of the day, the angle of sunlight, the heating of the ground, and the rhythm of life near the surface. It is a quiet piece of geometry with enormous consequences. It makes the mornings brighter. It stretches the evenings longer. It warms lakes, sidewalks, forests, fields, rooftops, gardens, and beaches. It gives plants more hours of light to use. It gives people more daylight after work, after school, after dinner, and after the ordinary duties of the day. A summer evening can feel personal, but its first cause is planetary. The warm air outside the window begins with Earth leaning toward the sun. The late sunset begins with a hemisphere spending more time in daylight. The golden feeling of the season begins with sunlight arriving at a stronger angle. And that light does more than warm the ground. It enters the eyes, reaches deep timing centers in the brain, and helps the body turn daylight into biology. A summer morning begins working on the body before a person thinks about the season at all. Light enters through the clear front surface of the eye, passes through the pupil, and reaches the retina at the back. The retina is a thin layer of nerve tissue. It contains the cells that help turn light into signals the brain can use. Some retinal cells help create vision, letting a person see color, shape, motion, and detail. A smaller group has a different job. These cells are especially sensitive to brightness. They contain a light-sensitive pigment called melanopsin. Melanopsin responds strongly to blue-rich daylight, the kind of light that fills the sky after sunrise and stays bright through long summer afternoons. When these cells detect light, they send signals along a pathway into the brain. Those signals reach a tiny area called the suprachiasmatic nucleus. It is often shortened to SCN. The SCN sits in the hypothalamus, a small but important part of the brain involved in temperature, hunger, hormones, and daily body rhythms. This little cluster of cells acts like the body's master clock. It helps organize the circadian rhythm, which is the body's roughly 24-hour cycle. Circadian comes from words meaning about a day. This rhythm helps decide when the body feels awake, when it starts preparing for sleep, when temperature rises and falls, and when certain hormones are released. Light is one of the strongest signals that sets this clock. Morning light helps tell the body that the day has begun. It anchors the timing of wakefulness. It helps the brain line up the inner day with the outer day. During summer, that signal can arrive early and last for many hours. In some northern cities, daylight can stretch far into the evening. In Toronto, near the June solstice, the sun can rise around 5:35 in the morning and set around 9 o'clock at night. Farther north, the effect grows stronger. In places like Anchorage, Alaska, the longest days can bring more than 19 hours of daylight. Above the Arctic Circle, the sun can stay above the horizon for a full 24 hours during part of the summer. Most people do not live under midnight sun, but even a few extra hours of daylight can change the shape of a day. Evening light can delay the body's sleep signal. One important sleep-related hormone is melatonin. Melatonin rises in the evening when darkness tells the brain that night is coming. Bright light can suppress or delay that rise. That is one reason summer nights can make people feel awake later than they expected. The clock on the wall may say it is time to wind down. The sky may still be pale blue. The trees may still be visible. People may still be walking dogs, sitting on porches, playing sports, or talking outside. The body reads those signals. It receives them through the eyes. Long daylight can make the same 24-hour day feel wider. A winter evening can seem to close quickly. A summer evening can feel as if there is still room left inside it. Dinner ends, and the day has not fully ended with it. A person can go for a walk, water a garden, sit near a window, or hear children playing outside while the sky is still bright. This is one reason summer can feel like extra time. The planet has not added more hours. The light has changed how the hours feel. The body's clock is being pulled gently by sunrise, sunset, and brightness. The season begins outside, with Earth leaning toward the sun. Then it moves inward, through the eye, into the brain's timing system. And once daylight reaches that inner clock, it begins shaping more than sleep. It changes alertness. It changes energy. It changes the emotional weight of the day. Once daylight reaches that inner clock, it begins to shape the whole feeling of the day. Bright light is one of the clearest signals the body receives. When morning light enters the eyes, special cells in the retina send messages toward the brain's timing center. Those messages help tell the body that daytime has arrived. Melatonin, the hormone that rises in darkness and helps prepare the body for sleep, becomes lower when bright light is present. That is one reason a clear summer morning can feel so alerting. The room is brighter. The window glows earlier. The sky carries more blue light, which is especially strong at signaling daytime to the nervous system. A person may wake before an alarm, notice light around the curtains, and feel the day beginning before any plan has been made. This effect does not mean sunlight creates happiness by itself. Mood is shaped by many things, including sleep, stress, food, health, relationships, work, and memory. Still, light is one real part of the system. Doctors can see this most clearly in seasonal affective disorder. Seasonal affective disorder is a pattern where some people experience low mood during darker parts of the year, especially in late fall and winter. It is more common in places with short winter days, where morning light arrives late and evening darkness comes early. For some people, bright light therapy is used as a treatment. A special lamp shines strong light toward the eyes in the morning, helping the body receive a clearer daytime signal when natural sunlight is limited. That simple treatment shows how deeply light can affect timing, alertness, and emotional rhythm. Summer gives many people this signal naturally. The sun rises earlier. The daylight is stronger. Outdoor spaces become brighter for more hours. A walk at 8 in the morning may already feel fully lit. A street that looked dull in February can look wide and open in July. Leaves reflect sunlight from every side of a tree. Car windows shine. Water flashes with moving light. Even shadows look different, with sharper edges at midday because the sun climbs higher in the sky. The body also responds to sunlight through the skin. Sunlight contains ultraviolet radiation, a kind of light with wavelengths shorter than visible violet light. One type, called UVB, helps start vitamin D production. When UVB reaches the skin, it changes a molecule called 7-dehydrocholesterol into a vitamin D precursor. A precursor is an early form of a substance that the body can later turn into something useful. After that first step, the liver and kidneys help convert it into the active form of vitamin D. Vitamin D helps the body absorb calcium and supports bones, muscles, and immune function. The amount made in skin depends on many things. Latitude matters. Season matters. Skin tone, cloud cover, time of day, clothing, sunscreen, and age all change how much UVB reaches the skin. In northern places, winter sunlight can be too weak for much vitamin D production because the sun stays low and UVB is filtered through more atmosphere. During summer, the sun climbs higher and UVB becomes more available during the middle of the day. This does not make sun exposure harmless. The same ultraviolet light that helps start vitamin D production can also damage skin cells. Too much UV can cause sunburn, speed skin aging, and increase the risk of skin cancer over time. Summer light carries both usefulness and risk, which is why shade, clothing, and sunscreen matter. Still, in small and ordinary ways, sunlight gives the body a powerful message. It tells the brain that the day is active. It helps set the sleep-wake cycle. It reaches the skin and begins a chemical process tied to vitamin D. It makes surfaces brighter, colors clearer, and evenings feel more open. This is one reason summer can feel as if the outside world has turned its volume up gently. The body receives more daytime from every direction. From the sky above, from the light entering the eyes, from the warmth beginning to gather on the skin. And as brightness becomes warmth, the season changes from something seen into something felt. That brightness is joined by a second summer signal. The skin understands right away: warmth. The human body keeps its core temperature close to 37 degrees Celsius. That number can shift a little from person to person, and it rises and falls slightly through the day. Even while sitting still, the body is always working to stay near its safe internal range. Blood vessels open or narrow. Sweat glands turn on or stay quiet. Muscles can tense, shiver, relax, or move the body towards shade, water, clothing, or shelter. Temperature is never just something around us. It becomes a task the body is constantly solving. In winter, that task often requires more effort. Cold air pulls heat away from exposed skin. Blood vessels near the surface narrow in a process called vasoconstriction, which means they tighten to keep more warm blood near the body's center. If the body needs more heat, muscles begin to shiver, making tiny, rapid contractions that generate warmth. A person stepping outside in January may zip a coat, pull on gloves, lower their chin into a scarf, and move quickly from one warm place to another. The world can still be beautiful in cold weather, but the body often meets it through layers. Wool, down, leather, glass, closed doors. Summer changes that physical relationship. When the air is mild, the body does not have to defend itself as strongly from the outside. A short-sleeved shirt may be enough. A hand can rest on a porch railing without pulling back from cold metal. Bare feet can touch wood, grass, sand, or warm stone. Skin has temperature receptors, small nerve endings that respond when the surface of the body warms or cools. Those signals travel through nerves toward the spinal cord and brain, giving the body a steady map of the air around it. On a comfortable summer evening, that map can feel soft and easy. Warm air rests against the arms. A breeze moves across the neck. The body can stay outside without preparing for battle. This is one reason summer can feel like permission. A person can sit after dinner without putting on heavy boots. A window can stay open long enough for the sound of leaves and distant traffic to drift inside. People gather on patios because the chair, the table, and the air all feel usable. Children run through grass without thinking about mittens or frozen ground. Swimmers step into lakes, pools, and oceans because warm weather makes cold water feel refreshing instead of harsh. The change is simple, but its effect is large. Warmth lowers the barrier between the body and the world. Muscles often feel less guarded in mild heat. Shoulders drop more easily. Hands stay loose. Walking can feel slower because the air no longer pushes the body to hurry toward shelter. A park bench becomes somewhere to stay. A sidewalk becomes a place to wander. A porch becomes an extra room, added to the house by weather alone. The built world also changes under summer warmth. Restaurants move tables outside. Public pools open for the season. Baseball fields, tennis courts, beaches, boardwalks, and playgrounds fill with movement. In many cities, street festivals and outdoor concerts depend on the same basic fact. Bodies are more willing to remain outdoors when the temperature feels safe and comfortable. Warmth also changes posture in small ways. People lean back. They stretch out on towels. They sit with open hands and uncovered arms. The body takes up space differently when it is not bracing against cold. Even clothing becomes lighter and less restrictive. Cotton shirts, sandals, linen, bathing suits, and sun hats all make summer feel more open because they let air and light reach the body directly. That direct contact matters. Sun on the forearm, warm boards under bare feet, lake air moving through damp hair, and a mild breeze through an open window all give the nervous system clear physical signals that the outside world is available. For a while, the boundary between indoors and outdoors feels thinner. A meal can move to the deck. A conversation can drift into the yard. A quiet evening can stretch beside an open window while the room slowly cools. Comfortable warmth makes the season feel easier to enter because it asks less of the body before pleasure can begin. Yet the same heat that opens the door can keep rising. The body welcomes warmth only within a careful range, and summer's softness begins to change when cooling becomes hard work. Comfort has a boundary. A summer afternoon can feel gentle when the air is warm enough to loosen the body, while still cool enough for the body to release heat easily. As the temperature keeps rising, that same warmth begins asking for more work. The skin grows damp. The face may flush. Movement feels slower. A short walk across a parking lot can feel heavier than expected, especially when the pavement has been holding sunlight for hours. The body's main cooling tool is sweat. Sweat glands bring water to the surface of the skin. When that water evaporates, meaning it changes from liquid into vapor, it carries heat away from the body. This is why a breeze can feel so good on a hot day. Moving air helps sweat evaporate faster. The cooling does not come from sweat simply sitting on the skin. It comes from the sweat leaving the skin. Evaporation is the quiet escape route for heat. Humidity makes that escape harder. Humid air already holds a lot of water vapor, so sweat has a slower time evaporating into it. A 30 degrees Celsius day can feel manageable when the air is dry. The same temperature can feel heavy and sticky when humidity is high. The body keeps sweating, yet less heat leaves the skin. Clothing may cling. Hair feels damp. Shade helps, though the air itself still feels loaded. This is why weather reports often include the heat index. The heat index combines air temperature and humidity to estimate how hot the weather feels to the human body. It is not measuring the thermometer alone. It is estimating the body's cooling challenge. On a humid summer day, the heat index can be several degrees higher than the actual air temperature, because the body is struggling to cool through evaporation. Dehydration makes the challenge even harder. Sweat is made mostly of water, with small amounts of salt and other dissolved minerals. When the body loses too much fluid, it has less water available for sweating and blood flow. The heart may have to work harder to move warm blood toward the skin, where heat can leave the body. This is why water, shade, slower movement, and rest matter so much in hot weather. Summer pleasure depends on the body staying within a safe working range. When heat rises too far, the season can feel draining instead of freeing. Heat exhaustion is one example of the body being overburdened by heat. It can bring fatigue, dizziness, headache, nausea, or a weak feeling after too much time in hot conditions. The details do not need to be dramatic to be taken seriously. The body is simply signaling that cooling has become difficult. Night brings its own version of this balance. Sleep usually begins more easily when the body can cool down. In the evening, core temperature naturally starts to dip as part of the sleep-wake cycle. Warm blood moves toward the skin, especially in the hands and feet, helping the body release heat. A cool bedroom supports that process. A hot room interferes with it. The sheets feel too warm. The pillow holds heat. Small movements become noticeable. A person may wake more often or spend longer trying to fall asleep because the body is still working to cool itself. This is why a summer night can feel peaceful with an open window and a light breeze, yet restless when the air stays trapped and humid. The same season that gives long evenings can also make sleep shallower when the heat lingers after dark. The difference often comes down to whether the body can release heat faster than it gains it. Summer's best warmth has a gentle range, enough heat to make a lake inviting, enough softness to sit outside after dinner, enough mild air to leave a window open while the room slowly darkens. The season feels generous when warmth supports the body instead of burdening it. That balance often arrives most beautifully in the evening. When the daylight remains, the ground begins to cool, and the harshest heat finally starts to loosen its hold. As afternoon lowers toward evening, summer often reaches its most comfortable hour. The pavement still holds some of the day's heat. The harshest sunlight begins to soften. shadows grow longer across lawns, sidewalks, fields, and porches. The air may still be warm, yet the body no longer has to work as hard against the full strength of the afternoon. This is where summer begins to feel spacious. The day seems to keep going after the usual duties are finished. Dinner can happen while the sky is still bright. A walk can begin at 8 p.m. without feeling late. A park can stay lively after work. A lake or pool can still hold swimmers after the hottest part of the day has passed. This feeling has a real astronomical cause. Around the June solstice, many places in the middle latitudes experience their longest days of the year. The June solstice usually falls on June 20th or June 21st in the Northern Hemisphere. That is when the sun reaches its highest noontime position of the year for places north of the equator. The latest sunsets, however, often arrive a few days after the solstice in many mid-latitude regions. This happens because clock time and solar time do not line up perfectly through the year. Earth's orbit is slightly oval, and its tilted axis changes the timing of solar noon by small amounts. The result is subtle, but people can feel it. Near late June, the evening light seems to linger. In a city around 40 to 45 degrees north latitude, places like New York, Toronto, Boston, Chicago, or northern Italy, sunset can come close to 8:30 or 9 p.m., near the longest days. Farther north, the evening stretches even more. In Edinburgh, Scotland, twilight can last deep into the night near midsummer. In Oslo, Norway, the sky may remain pale for hours after sunset. Even after the sun drops below the horizon, daylight does not vanish at once. It passes through twilight. Civil twilight is the first stage after sunset. During civil twilight, the sun is less than 6 degrees below the horizon. There is still enough natural light for many outdoor activities without artificial lighting. The sky may turn peach, lavender, grey-blue, or gold. Street lights begin to glow, yet the world is still visible. Tree branches keep their shape. Faces can still be recognized. The edge of a lake may hold a strip of reflected light. This extra brightness changes how the evening feels. During darker months, work, school, errands, and chores can seem to use up most of the daylight. By the time the day's responsibilities end, the outside world may already feel closed. In summer, daylight remains after the structured part of the day has loosened. That remaining light changes behavior. People sit on patios. Dogs get walked later. Neighbors water gardens. Children keep playing on driveways or grass. Restaurants open their windows. Basketball courts, tennis courts, trails, boardwalks, and beaches stay active. The body reads the light as daytime, while the schedule reads the hour as evening. That overlap can make summer evenings feel like extra time. The nervous system is still receiving brightness. The calendar is no longer demanding the same pace. The air has cooled just enough for slower movement. A person can wander without a clear purpose. A chair outside becomes more inviting than a chair inside. An open window lets in voices, birds, insects, passing cars, and leaves moving in the mild air. The evening becomes a soft extension of the day, added after the required parts are mostly complete. This is one of summer's strongest emotional signatures. Long light makes ordinary life feel less compressed. A short walk can become a small event. A simple dinner can move outdoors. A few minutes beside a pool, a lake, or a porch railing can feel larger than the clock says. The feeling comes from light, heat, timing, and habit all meeting in the same hour. Summer evenings feel generous because the world stays available after the day should have begun closing. Yet that sense of permission does not come from the sky alone. Long before people notice the solstice or the angle of twilight, they learn that summer has a special place on the calendar. That learned place begins early for many people. Summer becomes the part of the year when the clock seems to loosen. School doors close for weeks. Backpacks hang untouched. Morning alarms become less strict. A weekday can feel almost like a Saturday, even when the sun has risen at the same hour. In many school systems across North America and Europe, summer includes a long break from regular classes. The exact dates vary by country, province, state, district, and school board. Some students finish in late May. Others continue into June or July. Some return in August. Others return in September. Yet the larger pattern is familiar. Summer often carries a pause in the ordinary school rhythm. That pause has helped shape the emotional meaning of the season. The history behind it is more layered than the simple story people often hear. A common explanation says children were given summer vacation because farms needed them during the growing season. Farm work did matter in some places, especially in rural communities where school calendars followed local needs. But farming alone does not explain the modern summer break. In many agricultural areas, spring planting and autumn harvest could be more demanding than midsummer. Some rural schools in the 1800s even had winter and summer terms, with breaks placed around the busiest farm periods. Cities followed different patterns. In the 19th century, many urban schools were hot, crowded, and poorly ventilated during the warmest months. Modern air conditioning did not become common in schools until much later in the 20th century. A classroom packed with students in July could become difficult to teach in, especially before electric fans, reliable cooling, and modern building standards. As cities grew, families with enough money sometimes left for cooler places in summer. They traveled to seaside resorts, mountain towns, lakes, and rural retreats. Schools gradually had to fit around these habits, along with local weather, teacher schedules, and the growing push to standardize calendars. Over time, summer break became a normal part of the year. Once a calendar becomes normal, it begins to feel natural. Children learn that summer means less structure. Parents plan trips around it. Businesses prepare for tourist season. Camps, pools, beaches, and parks expect larger crowds. The feeling of summer becomes supported by institutions, schedules, and habits. Summer camps help strengthen this meaning. In the late 19th and early 20th centuries, camps became popular in North America, especially among urban families who wanted children to spend time outdoors. Fresh air, swimming, canoeing, hiking, campfires, and cabins were seen as healthy escapes from crowded city life. Some camps were built near lakes. Others were placed in forests, mountains, or open countryside. By the early 1900s, summer camp had become part of childhood for many families who could afford it. The idea was simple and powerful. Summer was a time when children could leave ordinary rooms and enter a wider outdoor world. Tourism followed a similar path. Railways made summer travel easier in the 1800s. Coastal towns, lake resorts, and mountain hotels grew around seasonal visitors. In the 20th century, cars opened new routes for family trips, roadside motels, national parks, beaches, and cottages. Paid vacation time also became more common for workers in many countries, though access has always depended on job type, income, and local labor laws. A long weekend in July, a week at a lake in August, a road trip to a national park, a rented cottage with screen doors, towels on railings, and sand in the car. These patterns teach people to expect summer as a season of release. That expectation matters. The body receives more light and warmth, while the calendar says life may become less restricted. The season gathers meaning from both directions. A child counting the final school days, a family circling dates on a kitchen calendar, a worker saving vacation days for the warmest month, a town preparing its beach, marina, boardwalk, or campground. Summer begins to feel good before anything has happened, because the year itself points toward a possible break. The pleasure starts to arrive in advance, carried by plans, images, and the quiet hope of time that belongs more fully to you. A circled date can change the shape of an ordinary week. It might be a beach day marked on a calendar, a cottage booking in August, a flight confirmation sitting in an inbox, a long weekend planned around a lake, a hotel pool, a family visit, or a quiet road trip. Even before the trip begins, the brain starts building pieces of it. It pictures the first warm morning away from routine. It imagines towels drying on a railing, a suitcase on the floor, sandals by the door, or a car packed before sunrise. This is one reason summer can feel good before anything has actually happened. Anticipation is part of the reward system. The brain does not only respond after a reward arrives, it also responds while expecting one. Dopamine is one of the chemicals involved in this process. It helps with motivation, wanting, learning, and reward prediction. Reward prediction means the brain is estimating that something good may be coming. That estimate can pull attention forward. A person may feel lighter during a workday simply because Friday evening has a plan attached to it. A student may feel the final week of school differently because the break is almost close enough to touch. The future begins to color the present. Planning creates a kind of mental rehearsal. A beach trip may begin as a search for parking, sunscreen, weather, towels, snacks, and the best time to leave. A road trip may begin with a map, a playlist, a cooler, and the quiet thought of highway signs passing by. A cabin or cottage may begin with images of pine trees, wooden steps, lake water, and a screen door opening into warm air. The body has not gone anywhere yet, but the brain is already leaving the usual pattern. That matters because vacations often combine several powerful ingredients. They bring novelty, which means new surroundings or changed routines. They bring autonomy, which means having more control over how time is spent. They often reduce obligation, even if only for a short while. They place the body in a different environment, where the view, sounds, temperature, food, and pace all change together. A person may wake in a hotel room and need a moment to remember where they are. A child may step out of a tent and smell damp grass, lake air, and last night's smoke from a fire pit. A family may stop at the same roadside stand every July for peaches, cherries, corn, or ice cream. These small changes give the brain new details to process. Routine becomes thinner. Attention has more fresh material to hold. Even modest summer plans can change the emotional weight of a week. A Saturday barbecue gives Thursday a different feeling. A Sunday swim gives Monday something to move toward. A short evening at a park, a public pool, or a neighborhood patio can make the whole day feel less closed in. The event itself may last only a few hours, yet anticipation stretches its effect across time. That is why summer happiness often begins in fragments. Checking the forecast, buying a new bottle of sunscreen, setting aside a bathing suit, filling a cooler, charging a camera, choosing a book for the beach, looking at the same date again and again as it gets closer. None of these details is the vacation itself. Each one gives the nervous system a small signal that ordinary life may soon loosen. The strongest summer plans often involve a change in place. Humans are sensitive to environmental cues. A different view can change attention. Different sounds can change alertness. Different routines can change how time feels. This is why even a nearby lake or a public beach can feel like a real escape. The distance may be short, but the sensory world changes sharply. Pavement becomes sand. Traffic becomes waves. Indoor air becomes wind moving over open water. Summer feels good as an experience, and it also feels good as something approaching. The brain can begin enjoying relief, while relief is still on the horizon. For many people, the image waiting at the end of that anticipation is water, spread out under sunlight, cool enough to enter, wide enough to make the day feel open. At the edge of a shoreline, summer takes on a different shape. Heat no longer feels like something the body has to simply endure. It has an answer. A lake, a river, a pool, a sprinkler, or the wide surface of the ocean gives warmth somewhere to go. The body understands this quickly. Step from hot sand into shallow water, and the skin changes its message almost at once. Water pulls heat away from the body more efficiently than air, because water is denser and makes closer contact with the skin. This is why a pool at 24 degrees Celsius can feel much cooler than air at the same temperature. The number may match, but the body experiences it differently. Water carries heat away through direct contact. Every movement of a hand, leg, or shoulder brings fresh water across the skin. That is part of why swimming can feel so relieving in summer. The body cools while still moving. The muscles work. The skin releases heat. And the pressure of water holds the body in a way air never can. Even standing knee-deep in a lake can change the entire mood of a hot day. The feet settle into sand, mud, pebbles, or smooth stone. Small waves move against the ankles. Light breaks into shifting patterns across the surface. The horizon opens wider than an ordinary street or room. Researchers sometimes use the term blue space for visible water environments. Blue space can mean oceans, lakes, rivers, ponds, canals, coastlines, or other places where water is part of what people see and experience. The idea is simple. Water changes the sensory field around a person. It gives the eyes a broad surface to follow. It gives the ears repeating sounds. It gives the skin cooler air, mist, spray, or direct contact. It gives attention a gentle rhythm, because waves, ripples, and currents move without needing anything from us. This does not mean water automatically makes every person calm. A crowded beach, rough surf, deep water, or a noisy pool can feel stressful depending on the person and the setting. Still, water environments are widely studied because many people experience them as restorative. A shoreline often has fewer sharp visual edges than a busy city block. The eye can rest on distance. The ear can follow repeated sounds like waves reaching shore every few seconds, water tapping against a dock, or a pool filter humming softly behind the splash of swimmers. A beach gathers many summer signals in one place. There is sunlight on the water. There are towels spread across sand. There are coolers, umbrellas, sunglasses, sandals, and footprints. Children dig with plastic shovels. Gulls circle above piers. Farther out, boats move slowly across the line where water meets sky. At a lake cottage, the same pool can feel quieter. A dock warms in the afternoon. A canoe knocks gently against its rope. Pine needles gather near the steps. Wet swimsuits hang from a railing. The surface of the lake changes with every breeze, from smooth glass in the morning to small silver ripples by evening. Rivers add another kind of movement. Their water travels in one direction, carrying leaves, bubbles, foam, and reflected light downstream. A person sitting beside a river does not need to make the motion happen. The landscape moves on its own. Pools create a more human version of the same relief. Blue tiles, ladders, painted depth numbers, floating toys, and the sharp, clean smell of treated water make their own summer language. Even a backyard sprinkler can turn heat into play. Drops catch the sunlight for a moment, strike the grass, and cool the air close to the ground. Water gives summer a place of release. It turns the season from pure exposure into contact, sound, reflection, and relief. The heat remains part of the day, but water gives it movement and direction. That same water also shapes the air nearby, because lakes and oceans store heat in a slower, deeper way than land. A shoreline has its own summer weather. Stand a few streets inland on a hot afternoon, and the air may feel still and heavy. Step closer to a lake or ocean, and the temperature can seem to loosen. The change can be small, sometimes only a few degrees, yet the body notices it. Water has a special way of handling heat. Scientists describe this with a term called specific heat capacity. It means the amount of energy needed to raise the temperature of a substance. Water has a high specific heat capacity, about 4.18 joules per gram for every 1 degree Celsius of warming. That number means water needs a lot of energy before its temperature changes. Land usually responds faster. Sand, soil, rock, pavement, rooftops, and walls can heat quickly under strong sun. A sidewalk can become hot enough to shimmer. A parking lot can hold the day's heat, like a dark plate. A beach towel on dry sand may warm within minutes, while the nearby lake remains cool enough to enter slowly. This difference creates one of summer's gentlest weather patterns. During the day, land heats faster than nearby water. The air over the land warms, expands, and rises. As that warmer air lifts, cooler air from over the water can slide inland to replace it. This moving air is called a sea breeze near an ocean, or a lake breeze near a lake. It can arrive quietly. A flag begins to turn. Leaves on shoreline trees start moving from the direction of the water. The air smells a little cooler, a little wetter, and sometimes faintly mineral or salty, depending on the place. Around the Great Lakes, these lake breezes can shape summer afternoons in cities like Toronto, Cleveland, Chicago, Buffalo, and Milwaukee. A neighborhood close to the water may feel cooler than an inland suburb during the same hour. Along ocean coasts, the same process helps explain why beaches can feel gentler than streets, only a short distance away. The breeze is created by uneven heating. The land warms quickly. The water warms slowly. The atmosphere tries to balance the difference by moving air. Water also cools the air through evaporation. Evaporation happens when liquid water becomes water vapor and enters the air. That change requires energy. Some of that energy comes from heat near the surface. So evaporation can help cool the local environment. A lake, river, pool, or ocean surface is always exchanging moisture with the air above it. On a breezy day, that exchange can make shoreline air feel softer against the skin. The effect is especially noticeable after walking across a hot road, then reaching a shaded dock or grassy bank near water. The contrast with cities can be strong. Asphalt and concrete absorb sunlight during the day. Buildings store heat in walls, roofs, windows, and brick. After sunset, those surfaces release heat back into the air. This is part of the urban heat island effect, where cities stay warmer than nearby rural or natural areas. A downtown street can remain hot late into the evening because the materials around it have been storing energy all day. Cars, air conditioners, and traffic add more heat. Tree cover, grass, and water can soften that effect. A park with a pond, a shaded river trail, or a waterfront path may feel noticeably different from a wide road lined with dark pavement. Small local differences like this are called microclimates. A microclimate is a tiny climate within a larger area. The shady side of a house has one. A sunlit balcony has one. A beach, marina, forest edge, garden, or lakeside path can have one too. Shoreline microclimates often feel cooler during hot afternoons because water stores heat slowly, supports breezes, and adds moisture to the air. This is why a beach day can feel like a softer version of summer. The sun is still bright. The season is still warm. The body is still surrounded by heat and light. Yet water changes the terms of the day. It cools the skin. It moves the air. It slows the rise of temperature. It gives summer a gentler edge. That gentleness reaches beyond weather because summer is also carried through taste. Cold fruit, ripe gardens, smoky grills, and meals that seem to belong outside. A slice of watermelon can feel almost like shade you can eat. Its red flesh is roughly 92% water, which is why it seems to cool the mouth so quickly on a hot day. Cucumbers are even more watery, about 95% water by weight. They crunch because their cells are full of fluid held inside thin plant walls. When foods like these are served cold, the relief comes from two simple sources. They bring water into the body. They also bring a lower temperature to the mouth, tongue, and throat. That cool feeling is real, even though a few bites of fruit or a glass of lemonade do not greatly lower the body's core temperature. The comfort is local and immediate. Ice cream melts across the tongue. Lemonade feels sharp and cold against the teeth. A chilled peach releases sweet juice that runs over the fingers before anyone can catch it. Summer foods often seem refreshing because they combine water, sweetness, acidity, and temperature. Acidity is the bright sour quality found in lemons, limes, berries, and some tomatoes. It wakes up the mouth and makes sweet foods taste clearer. This is why lemonade can feel so lively in hot weather. The sugar gives quick sweetness. The lemon juice adds sharpness. The cold water carries both across the tongue. Warm months also bring ripeness. In many temperate places, strawberries arrive in late spring and early summer. Cherries often peak in early to midsummer. Peaches, nectarines, plums, tomatoes, corn, blueberries, raspberries, and melons follow through the warmer weeks, depending on the region. Ripening is a real plant process. As fruit matures, starches can turn into sugars. Acids can soften. Aromas become stronger. Cell walls loosen, making fruit softer and juicier. A firm green peach on a counter slowly becomes fragrant because its chemistry is changing inside. Tomatoes shift from green to red as pigments like lycopene build in the fruit. Corn tastes sweetest soon after harvest because its sugars begin converting into starch after the ear is picked. This is why fresh summer corn can taste so different from corn that has traveled for days. A farmer's market in July or August carries that change in plain sight. Wooden crates fill with berries in paper boxes. Tomatoes sit in uneven shapes and deep colors. Corn husks feel cool and slightly damp when peeled back. Melons sound hollow when tapped. The season becomes visible as food. Summer also has the flavor of heat. Grilling changes food through chemistry. One important process is called the Maillard reaction. It happens when amino acids, which are building blocks of proteins, react with sugars under high heat. This reaction helps create the browned flavor on grilled meat, toasted bread, roasted vegetables, seared corn, and even the golden edges of burger buns. The smell rising from a grill is partly the smell of these new flavor compounds forming on hot surfaces. Barbecue smoke adds another layer. When wood or charcoal burns, it releases aromatic compounds into the air. Aromatic compounds are tiny molecules that can carry strong smells. Some settle onto food, giving it a smoky flavor. Different woods can create different notes. Hickory may smell strong and bacon-like. Applewood can be milder and slightly sweet. Mesquite burns hot and gives a bold smoke, often used in parts of the American Southwest. Outdoor food also changes the setting of eating. A meal on a picnic blanket feels different from the same food at a kitchen table. Paper plates, coolers, Napkins held down by cups, sliced tomatoes, grilled corn, and fruit passed from hand to hand all make food part of the weather. People eat while air moves around them. They hear insects in grass, children in water, a screen door, a dog barking down the street, or foil being opened over a tray of food. The pleasure comes from taste and from place working together. Summer becomes something the mouth can recognize. Cold melon, sweet corn, charred edges, tart lemonade, ripe berries staining fingertips. Yet taste is only part of flavor. Much of what people call taste is carried by smell, and summer's scents can reach memory with surprising speed. A familiar scent can return an entire place before the scene is fully formed. Sunscreen on warm skin, cut grass drying in the afternoon, lake water on a towel, chlorine near a public pool, barbecue smoke drifting over a fence, rain hitting hot pavement after a dry week. Each smell is carried by tiny airborne molecules. When those molecules enter the nose, they reach a patch of tissue high inside the nasal cavity, called the olfactory epithelium. That tissue holds smell receptors. Different molecules fit different receptors, and the pattern of activation helps the brain identify the scent. The signal then passes through the olfactory bulb, a small structure at the front of the brain that helps organize smell information. From there, smell has unusually close connections to areas involved in emotion and memory. Two important regions are the amygdala and the hippocampus. The amygdala helps process emotional meaning. The hippocampus helps form and retrieve memories of places, events, and experiences. This close connection is one reason a smell can feel so fast. A song may remind someone of a summer. A photograph may show a summer. A smell can seem to open the door at once. The scent of coconut sunscreen might bring back a beach towel, a plastic cooler, and the feeling of sand sticking to damp feet. The smell of lake water may bring back a dock, a canoe paddle, a wet rope, and the hollow sound of small waves under wood. A pool has its own summer smell, though it is often misunderstood. People usually call it the smell of chlorine. Much of that sharp pool scent actually comes from chloramines. Chloramines form when chlorine reacts with sweat, body oils, urine, and other organic material in the water. A clean, well-managed pool may have less of that strong smell than people expect. Still, for many people, even a faint trace of it can bring back swimming lessons, goggles, painted depth numbers, tiled showers, and bare feet on warm concrete. Summer rain carries another kind of chemistry. After dry weather, rain can release an earthy scent called petrichor. The word describes the smell that rises when rain touches dry soil, stone, or pavement. One important part of that smell comes from geosmin. Geosmin is a compound made by soil bacteria, including bacteria in a group called Streptomyces. Humans can detect geosmin in extremely tiny amounts, which helps explain why wet soil can smell so strong after only a brief shower. When raindrops hit dry ground, they can trap small air bubbles. Those bubbles rise and burst, sending tiny scent-carrying particles into the air. That is why the smell of rain can seem to bloom suddenly from sidewalks, gardens, fields, and warm roads. Cut grass has its own signal. When grass blades are cut or crushed, the plant releases volatile organic compounds. Volatile means they evaporate easily and can travel through air. Some of these compounds are called green leaf volatiles. They are part of the plant's response to damage. Yet to a person walking past a freshly mowed lawn, they become the smell of a summer afternoon. That smell may carry images of baseball fields, backyard sprinklers, white sneakers stained green, and the steady hum of a mower moving in rows. Barbecue smoke adds heavier notes. Burning wood and charcoal release aromatic molecules that cling to air, clothing, and food. Smoke from hickory, oak, mesquite, maple, or apple wood can smell different because each wood contains its own mix of natural compounds. Warm air can help these scents travel and linger. A neighborhood in July can hold traces of grass, smoke, soil, flowers, sunscreen, asphalt, and water, all at the same time. This is why summer can return through the nose with such force. The season leaves chemical traces everywhere. Some are made by soil bacteria. Some rise from plants. Some come from water, smoke, skin, food, and rain. The body reads them quickly, and memory gives them shape. A single scent can become a path back to a place that no longer needs to be explained. Many of those smells begin in the living world at its busiest, where leaves, flowers, grasses, and trees are using long summer light to turn air and water into growth. Inside that green activity, summer becomes visible. A maple tree that looked thin in April can stand heavy with leaves by July. An oak canopy can spread wide enough to cool the ground beneath it. Grass grows quickly after warm rain. Tomato vines climb their cages. Corn leaves rise in long blades from the soil. Wildflowers open along roadsides, fields, trails, and fence lines. This fullness begins with sunlight. Plants use a process called photosynthesis. Photosynthesis means that a plant uses light energy to build food from simple ingredients. The main ingredients are carbon dioxide from the air and water drawn up from the roots. Inside the leaves, light energy helps turn those materials into sugars. Oxygen is released as a byproduct. Those sugars feed the plant. They help build stems, leaves, flowers, fruits, seeds, roots, bark, and new cells. A leaf is a quiet solar surface. It spreads itself into the light and collects energy through chlorophyll, the green pigment that helps plants capture sunlight. Chlorophyll absorbs certain wavelengths of light, especially red and blue, while reflecting much of the green light that reaches our eyes. That reflected green is part of why summer landscapes look so full and alive. A single leaf may seem small, yet a tree carries thousands of them. A mature oak can hold hundreds of thousands of leaves, each one adding to the tree's daily work. A field of corn can turn acres of sunlight into sugars stored in stalks, leaves, roots, and kernels. A tomato plant uses summer light to build green leaves first, then yellow flowers, then fruit that slowly changes color as pigments and sugars develop. Day length matters too. Scientists call the length of daylight in a 24-hour period the photoperiod. Many plants respond to photoperiod as a seasonal signal. Some use long days as a cue to grow quickly. Some use changing day length to time flowering. Spinach and lettuce, for example, can bolt in long, warm days, sending up flower stalks and shifting away from tender leaf growth. Other plants, like many varieties of chrysanthemum, flower when days grow shorter later in the season. Summer light helps organize plant behavior across gardens, farms, forests, and fields. Warmth also speeds many plant processes within a useful range. Roots take up water and minerals from the soil. Tiny openings on leaves, called stomata, open and close to manage gas exchange. Through stomata, carbon dioxide enters the leaf for photosynthesis, while water vapor can leave. That water loss is called transpiration. On a hot day, a large tree can move surprising amounts of water from soil into air through its leaves. This is one reason shade under trees can feel cooler than shade under a roof. The tree is blocking sunlight and also releasing water vapor from living leaves. Summer abundance gathers in layers. Grass thickens after rain because each blade is building new tissue from light and carbon. Berry bushes push sugars into raspberries, blueberries, blackberries, and currants. Apple and peach trees spend the warm months growing fruit around seeds. Beans climb. Squash leaves widen. Sunflowers follow the bright season with broad leaves and heavy heads of seeds. Even weeds in sidewalk cracks are part of the same summer engine, using warmth and light wherever they can find it. This plant growth changes the look of the world. Bare branches disappear behind green canopies. Lawns need cutting again and again. Gardens become crowded. Roadsides fill with Queen Anne's lace, clover, goldenrod, milkweed, and tall grasses. Shade becomes deeper. Air carries more pollen, plant oils, and the smell of warm leaves. Summer feels fuller because the world has physically filled in. More surface area is catching light. More stems are pushing upward. More flowers are offering nectar. More fruits are swelling around seeds. This green expansion also creates shelter. A dense maple crown gives birds a hidden place to perch. Tall grass gives insects cover. Milkweed leaves feed monarch caterpillars. Berry bushes feed robins, cedar waxwings, raccoons, foxes, and mice. Flowers draw bees, butterflies, beetles, flies, and moths. As plants build the summer world, other life begins to gather around them. The season becomes louder, busier, and more crowded because the green world has made room and food for countless small bodies moving through it. A flower is rarely alone for long in summer. A patch of clover may draw honeybees, bumblebees, small flies, and butterflies by late morning. A milkweed leaf may hold a monarch caterpillar chewing along its edge. A raspberry cane may hide beetles beneath the leaves. By evening, the same yard can become a different place, with crickets calling from the grass and small moths moving around porch lights. Much of this activity rises because insects respond strongly to warmth. Many insects are ectotherms. That means their body temperature depends heavily on the temperature around them. A mammal, like a fox or squirrel, can make internal heat and keep its body within a narrow range. An insect's muscles, digestion, movement, and calling patterns often speed up or slow down with the air. Warm summer weather lets many insects move, feed, mate, and fly more easily. That is why a garden can seem almost still on a cold spring morning, then busy and humming on a warm July afternoon. Crickets give summer one of its clearest night sounds. Their chirping comes from rubbing parts of their wings together. As the temperature rises, their muscle activity speeds up, and many cricket species chirp faster. In the late 1800s, a scientist named Amos Dolbear described a simple relationship between cricket chirps and temperature. The exact formula works best for certain species, especially the snowy tree cricket. But the idea is real. Warm nights often make cricket calls quicker. A listener lying near an open window can hear temperature written into rhythm. Cicadas make a louder summer sound. Male cicadas produce their calls using structures called tymbals. Tymbals are thin-ribbed membranes on the sides of the insect's abdomen. The cicada snaps them in and out very quickly, and the hollow parts of its body help amplify the sound. Some cicadas call from high in trees during hot afternoons, turning whole streets or forest edges into a steady electric buzz. In parts of North America, periodical cicadas emerge in huge numbers after 13 or 17 years underground. For a few weeks, the landscape fills with their calls, shells, wings, and sudden abundance. Fireflies bring summer into sight. Their glow comes from bioluminescence, which means light made by a living thing. Inside a firefly's light organ, a molecule called luciferin reacts with oxygen. An enzyme called luciferase helps the reaction happen. ATP, a small energy-carrying molecule used by cells, is also involved. The result is a cool yellow-green light with very little heat. A firefly flashing over grass is sending a signal, often connected to finding a mate. Different species can have different flash patterns, turning a meadow into a quiet code of moving lights. Mosquitoes belong to the same warm season world, though they are less welcome. Many mosquitoes lay eggs in standing water. A bucket, bird bath, clogged gutter, puddle, pond edge, or old tire can hold enough water for larvae to develop. Warm weather can speed their life cycle, allowing some species to grow from egg to adult in roughly a week or two under favorable conditions. That is why summer rain followed by heat can bring a sudden increase in mosquitoes around yards and wetlands. Birds are tied to this insect abundance. Many songbirds time their breeding so chicks hatch when food is easier to find. Even birds that eat seeds or fruit as adults often feed their young soft insects and caterpillars because growing chicks need protein. A pair of robins may cross a lawn again and again with worms or insects. Barn swallows may sweep over fields catching flying insects in the air. Chickadees, warblers, and wrens may search leaves for caterpillars hidden along stems and branches. Summer sound is built from all this motion. Bees vibrate inside flowers. Cicadas call from trees. Crickets mark the warm dark. Birds repeat short songs from fences, shrubs, gutters, and wires. At night, the yard keeps moving in smaller ways, with moths, beetles, spiders, ants, and fireflies working through the warm hours. The season feels alive because it is visibly and audibly active. Plants gather sunlight into growth, and animals gather around that growth for food, shelter, and mating. The same heat that fills leaves with insects and trees with calls also rises into the sky, carrying moisture upward until the air itself begins to build toward thunder. High above the warm ground, the atmosphere can begin to rearrange itself. A summer afternoon may start with still air, bright lawns, insects in the trees, and heat rising from roads and rooftops. Then the sky changes. A small white cloud grows taller. Its base darkens. The light across the yard becomes muted, as if a thin grey sheet has been pulled over the sun. Leaves turn their pale undersides in the wind. Birdsong quiets. A distant rumble rolls across the air. Summer storms often begin with heat and moisture. Warm air is less dense than cooler air, so it tends to rise. This rising motion is called convection. Convection is the same basic process that makes warm air above a stove lift upward. Only in the atmosphere it can happen on a much larger scale. On a humid summer day, rising air can carry water vapor with it. Water vapor is water in its gas form, invisible in the air. Warm air can hold more water vapor than cool air, which is why muggy summer afternoons can feel so heavy. As the warm air climbs higher, the surrounding pressure drops and the air expands. Expanding air cools. When it cools enough, some of the water vapor begins to condense. Condense means it changes from gas into tiny liquid droplets. Those droplets gather into clouds. At first, the cloud may look soft and harmless. If the rising air keeps feeding it from below, the cloud can grow upward into a tall tower. The great thunderstorm cloud is called cumulonimbus. Cumulonimbus clouds can rise many kilometers into the sky. Their lower parts may be dark with water droplets, while their upper parts can spread outward into a flat anvil shape where high winds stretch the cloud top sideways. Inside, the storm is full of motion. Warm air rises, cooler air sinks. Water droplets and ice particles move up and down through strong currents. Collisions inside the cloud help separate electrical charge. Different parts of the cloud become charged in different ways, and the electrical tension builds. Lightning happens when that charge suddenly discharges. It is a huge electrical spark, sometimes inside the cloud, sometimes between clouds, and sometimes between cloud and ground. The air around a lightning channel can heat extremely fast, reaching temperatures far hotter than the surface of the sun for a brief instant. That sudden heating makes the air expand explosively. The expanding air sends out a sound wave. That sound wave is thunder. Because light travels faster than sound, the flash arrives first, and the rumble follows after. A nearby strike can sound sharp and cracking. A distant one may arrive as a low, rolling sound, stretched by hills, buildings, trees, and layers of air. Rain begins when droplets inside the cloud grow heavy enough to fall. Some are pulled downward by sinking air. That sinking air is called a downdraft. As rain falls through drier air below the cloud, some of it evaporates and cools the air around it. The cooled air becomes denser and moves downward faster. When it reaches the ground, it can spread outward as a sudden gust. That is why the air can turn cool just before or during a summer storm. A porch that felt warm and still can suddenly fill with wind. Dust lifts from a road. Tree branches sway. Curtains move near open windows. Then rain strikes the roof, the leaves, the sidewalk, the grass, and the surface of puddles. After the storm, the world may smell different. Part of that fresh scent can come from petrichor, the earthy smell released when rain hits dry ground. Some people also notice an ozone-like sharpness after lightning, especially near storms, because electrical activity can affect oxygen molecules in the air. The heat has not vanished, yet it has changed form. Energy that spent the day building in sunlight, warm ground, humid air, and rising motion has moved through cloud, wind, rain, light, and sound. Summer becomes dramatic for a little while. The season that can feel slow and golden can also turn dark, electric, and suddenly cool. Those sharp changes are part of why summer stays with us, because a storm gives the body a whole scene to remember. A sudden storm can leave more than wet pavement behind. Years later, a person may still remember the exact color of the sky before the rain arrived. They may remember the smell of the sidewalk cooling down, the porch light flickering on early, or the sound of thunder rolling away after the storm had passed. Memory often holds on to scenes that arrive with strong sensory detail. The brain gives special weight to moments that feel unusual, emotional, or rich with information. Scientists call memory for specific lived events episodic memory. An episodic memory is the memory of something that happened in a particular place and time. A first swim in a cold lake. A late drive home with the windows open. A baseball game under bright evening lights. A night when the power went out during a thunderstorm and the whole house went quiet. These memories are different from general knowledge. A person may know that summer is warm, that July follows June, or that beaches have sand. Episodic memory carries the lived scene. The towel, the road, the voice, the smell in the air. The hippocampus, a structure deep in the brain, helps form these event memories. It helps connect details into a single experience, linking place, time, sound, smell, body position, and emotion. When an event has more distinct details, the memory can have more anchors. A routine day may have fewer anchors. Wake up, eat breakfast, answer messages, do chores, follow the same route, sit in the same room, sleep in the same bed. There may be nothing wrong with the day, yet it can blur into other days that looked almost the same. The brain often compresses repeated patterns because they require less new information. Summer can interrupt that sameness. A vacation changes the view from the window. A sleepover changes the sounds before bed. A beach changes the texture under the feet. A storm changes the light in the afternoon. A new place gives the brain fresh landmarks to store. Novelty means newness, and novelty helps memory because the brain pays closer attention when something differs from the expected pattern. This is why a single unusual summer day can seem larger in hindsight than a whole ordinary week. The day may contain more firsts. First time in a certain lake. First night in a cabin. First trip without a normal schedule. First campfire of the season. First time seeing fireflies in a field after dark. Each new detail gives memory another point to hold. Emotion also strengthens what gets stored. Excitement before a trip. Relief after reaching the water. Nervousness before jumping from a dock. Laughter during a family game. or calm after a storm can all make a scene more memorable. The event does not need to be dramatic. A quiet evening can become vivid if the body is fully present inside it. Warm air on the arms, crickets near the grass, a plastic chair on a deck, a bowl of cherries on the table, the smell of rainwater in soil. Summer often gathers these details because people change routines during the season. They stay outside later. They travel to unfamiliar places. They eat meals in yards, parks, cottages, and campsites. They swim, hike, play sports, visit relatives, sit by pools, or walk through streets that stay bright after dinner. Even a small break from routine can create a thicker memory. Looking back, the season can feel longer than it was, because memory is partly shaped by how many distinct episodes were stored. A month filled with repeated days may seem short afterward. A month filled with trips, storms, late nights, outdoor meals, and new places may seem wide and full. Summer becomes vivid because it gives memory more material. The season touches the skin, fills the ears, changes the light, shifts the schedule, and adds new scenes to familiar life. For many people, this pattern begins early, when summer first becomes linked with school ending, wider days, and the feeling that time has opened. During childhood, summer can attach itself to the calendar with unusual strength. The pattern repeats for years. Classes end. Lockers are emptied. Desks are cleaned. Report cards come home. A school building that shaped every weekday suddenly becomes a place left behind for weeks at a time. For many children and teenagers, that repeated break becomes the first deep lesson in what summer means. The season arrives with fewer alarms, fewer packed lunches, and fewer fixed hours spent in the same classroom. Morning can begin later. Breakfast may happen slowly. A bike can stay on the driveway. A swimsuit can dry over a chair and be used again the next day. These details matter because repeated experiences help teach the brain what to expect from a season. When summer returns again and again with looser structure, the body begins to recognize it as a different kind of time. The daylight is longer. The weather invites outdoor play. The calendar carries fewer school demands. Together, those signals can become an emotional template. A template is a pattern that later experiences are compared against. If a person first learns summer through school breaks, sprinklers, sleepovers, camp cabins, cottage roads, and staying outside after dinner, adult summer may still be measured against those early scenes. Childhood also tends to contain more new experiences than many adult years. A child may learn to swim in one summer. Another summer may bring a first overnight camp, a first roller coaster, a first fishing trip, or a first long drive to the ocean. Newness gives memory more edges. The first time walking barefoot across hot sand can stay clearer than the 10th time. A first jump from a dock can leave behind the color of the water, the sound of feet on wood, and the shock of cold around the ribs. The brain pays close attention when something feels new, and childhood supplies many moments that have never happened before. This helps explain why childhood summers can feel wide in memory. A summer break may last 8 or 10 weeks in many school systems. On a calendar, that is a short part of a year. To a child, it can feel enormous. Part of that feeling comes from scale. A child has lived fewer years, so one summer makes up a larger share of life already experienced. A 2-month break feels different to someone who has lived 8 years than it does to someone who has lived 40. Routine also shapes the feeling. Adult weeks often repeat around work, errands, bills, appointments, and the same daily routes. Childhood summer can include more open hours that are less tightly measured. A day might move from cereal to cartoons, from a backyard sprinkler to a bike ride, from a late dinner to catching fireflies near the grass. The schedule is still shaped by adults, weather, money, and place. Yet it can feel less divided into small required pieces. That looser structure gives memory room to stretch. Summer camp deepens the effect for many people. Camps became common in North America during the late 1800s and early 1900s, often built around lakes, woods, sports fields, cabins, and campfires. They offered children from growing cities a planned outdoor world, with swimming lessons, canoe paddles, bunk beds, nature trails, and evening songs. A camp week can become memorable because almost everything is changed at once. The bed, the meals, the sounds at night, the people nearby, and the rules of the day. Family trips can work in the same way. A motel pool beside a highway, a rented cottage with screen doors, a beach umbrella pressed into sand, a cooler filled with fruit, drinks, and melting ice. The place changes, and memory stores the difference. These early summer scenes can keep echoing long after childhood ends. A certain smell of sunscreen, a certain sound of sprinklers, or the first warm evening after a long winter can make adult life brush against something older. The feeling does not have to be dramatic. It may simply be a brief sense that the year has softened in a familiar way. Summer nostalgia grows from repeated early contact with freedom, novelty, warmth, and less controlled time. Those memories often begin privately, inside one family, one neighborhood, one school calendar, or one trip. Yet summer also reaches beyond private memory, because warm weather and long evenings bring many people into shared spaces at the same time. The private feeling of summer often spills outward. A warm evening can pull life from rooms into streets, yards, parks, beaches, and sidewalks. Porch lights turn on before the sky is fully dark. Neighbors water gardens. Dogs move slowly at the end of leashes. Children ride bikes in circles across driveways. Music slips through open windows and travels farther, because there is no closed wall between the sound and the air. This is one of summer's strongest social effects. Warm temperatures and longer daylight make outdoor gathering easier. People need fewer layers. Travel after work or school feels less difficult. A walk through a park can happen after dinner, because the path is still visible. A public bench, a picnic table, a splash pad, or a baseball diamond becomes more useful when the air is comfortable enough to stay in. The environment gives people more chances to cross paths. In colder months, many activities move indoors. Meals happen behind windows. Exercise moves to gyms. Conversations happen in kitchens, cars, offices, classrooms, and living rooms. Summer shifts part of daily life into visible space. Patios fill with tables. Boardwalks collect footsteps. Trails hold walkers, cyclists, strollers, and dogs. Playgrounds stay active later. Sports fields glow under evening lights. Beaches become temporary neighborhoods made of umbrellas, towels, coolers, sandals, and voices. A city can sound different in summer because more of life is exposed to the air. Basketballs hit pavement. Skateboard wheels click over sidewalk cracks. Distant lawn chairs scrape across decks. Food trucks idle near parks. At festivals, streets may close to traffic for a weekend, turning ordinary roads into places for tents, music, lights, and crowds. Outdoor concerts, farmers markets, night markets, street fairs, and community movie nights all depend on the same seasonal opening. The air allows people to gather without needing a building around them. This matters because social connection is strongly linked with well-being. Well-being means the overall sense that life feels supported, steady, and manageable. Humans are social mammals. The nervous system responds to faces, voices, shared attention, and the feeling of being near others. A short conversation with a neighbor, a wave from someone across the street, or the sound of families at a park can make a place feel more inhabited. Connection does not always need to be deep to change the mood of a day. Sometimes it is enough to feel that the world around you is awake and occupied. Summer creates more of these small contacts. A person walking after dinner may see the same people night after night. Someone sitting on a balcony may hear the same children playing below. A family eating outside may nod to another family passing by. People who live near beaches, lakes, trails, or parks can watch the season gather in waves. Morning runners, afternoon swimmers, evening walkers, and late-night groups carrying towels or takeout containers. The public world becomes more legible. Legible means easier to read. In summer, people can see what others are doing. They can tell that a park is active, a cafe is open, a beach is busy, or a neighborhood is settling into evening. That visibility can create energy. A quiet street with open windows and people on porches feels different from the same street sealed behind glass. A town square with tables outside feels different from a square people only pass through. The difference comes from behavior becoming visible. Life appears on the surface. At the same time, summer is not automatically social for everyone. Crowds can feel overwhelming. Travel can be expensive. Work schedules can continue through the hottest weeks. Some people feel lonely, even while others gather outside. The open season can make connection easier, yet it cannot guarantee it. Still, the pattern remains important. Summer often feels good because the world seems less closed off. Private routines loosen into shared spaces. A meal can move outdoors. A street can become a place to linger. A park can become a living room for a whole neighborhood. That openness is real, and it is uneven. The same sunlight, warmth, and public energy that feel generous in one life can become heavy in another when heat, cost, health, work, or isolation change what the season allows. For some people, the open season arrives with limits. A bright sidewalk can become hard to cross. A bus stop can feel exposed under full sun. An apartment can stay warm long after midnight because the walls, roof, and windows have absorbed heat all day. Summer pleasure depends on conditions that are not evenly shared. Light, warmth, and open time feel good. When the body can stay safe, hydrated, rested, and cool enough. When those supports are missing, the same season can become tiring. A heat wave is a prolonged period of unusually hot weather. The exact definition changes by region, because a dangerous temperature in one climate may be ordinary in another. In general, the risk rises when hot days continue and hot nights offer little relief. Nighttime matters because the body normally uses cooler evening air to recover. During sleep, core temperature tends to dip as part of the normal sleep-wake rhythm. Warm blood moves toward the skin, and heat leaves the body more easily when the room is cool. A hot bedroom works against that process. The pillow holds warmth. The sheets feel heavy. Sleep can become lighter and more broken because the body keeps trying to release heat. Cities can make this harder. The urban heat island effect happens when built surfaces absorb and re-radiate heat. Asphalt, concrete, brick, roofs, parking lots, and tall buildings collect solar energy during the day. After sunset, they release that stored heat back into the air. A tree-lined park can cool more quickly than a wide street surrounded by dark pavement. Dense neighborhoods with little shade may stay warm deep into the night. Someone in an upper apartment without air conditioning can experience summer very differently from someone sleeping near trees, water, or a cool basement. Sunlight also carries risk through ultraviolet radiation. The UV index measures the strength of sunburn-producing ultraviolet radiation reaching the ground. A higher UV index means skin can burn more quickly. Clear skies, midday sun, reflective sand, water, and high elevation can all increase exposure. Ultraviolet light can damage skin cells, which is why shade, hats, clothing, and sunscreen become part of summer safety. The same sunlight that helps set the body's clock and starts vitamin D production needs to be handled carefully. Air can become another limit. Wildfire smoke may travel hundreds or even thousands of kilometers from the fires that produced it. The smoke can carry fine particles called PM 2.5. These particles are smaller than 2.5 micrometers across, small enough to move deep into the lungs when breathed in. On smoky days, the sky may look pale orange or grey, and the sun can appear dimmed even at noon. For people with asthma, heart conditions, or sensitive airways, summer air can become a reason to stay indoors. Pollen adds another layer. Grasses, weeds, and trees release pollen at different times of year. In many regions, grasses are a major summer allergy source. Pollen grains can irritate the nose, eyes, throat, and lungs. Humidity can make the air feel heavier, while dehydration can make heat regulation harder. Outdoor workers face these limits directly. Roofers, farm workers, landscapers, construction crews, delivery workers, and lifeguards may spend hours in heat, while others are resting near shade or water. Older adults, very young children, people taking certain medications, and people without reliable cooling can face higher heat risk. Heat exhaustion can bring fatigue, dizziness, headache, nausea, or a weak feeling when the body is struggling to cool itself. These symptoms are signals that the body needs rest, cooler conditions, and fluids. Cost also shapes the season. Air conditioning uses electricity. Travel, camps, cottages, beach parking, gas, flights, hotel rooms, and time away from work all require access to money and time. A season built around freedom can feel painful when freedom is expensive. This does not erase the beauty of summer. It makes that beauty more specific. Summer feels good when warmth stays within a safe range, when rest is possible, when air is breathable, when water is reachable, and when the body can receive the season without strain. That fragility gives summer part of its preciousness, because even at its brightest, the light is already beginning to change. By late June, the longest daylight has already passed. In the Northern Hemisphere, the June solstice usually arrives on June 20th or June 21st. That is the point when the sun reaches its highest path across the sky for the year, and the daytime hours reach their peak. After that, the days begin to shorten. At first, the change is almost too small to notice. A few seconds are lost. Then a minute, then several minutes. By late July and August, the difference becomes visible at the edges of the day. Morning arrives a little later. Evening gathers a little sooner. The same street that stayed bright after dinner in early summer may begin slipping into shadow before the dishes are finished. Summer has a strange timing because the hottest weather often comes after the longest day. This delay is called seasonal lag. Land, lakes, oceans, roads, buildings, and soil store heat during the early summer. They keep absorbing energy even after daylight has started decreasing. Large bodies of water are especially slow to warm and slow to cool because water stores heat so well. That is why July and August can feel hotter than June in many places, even though June holds the longest daylight. The sun has started its slow retreat, while the Earth's surface is still holding the warmth it already received. Late summer carries that stored heat in a different way. The grass may look drier along roadsides. Leaves can hang heavier in still air. Cicadas call from trees with a rough electric sound. Cornfields stand tall. Tomatoes deepen on vines. Peaches, plums, blueberries, blackberries, melons, and sweet corn appear in markets, baskets, roadside stands, and kitchen bowls. The season begins to feel full, even as it quietly starts to close. In many regions, the light itself changes. Late August sunlight can look lower and more golden in the evening, because the sun's path is shifting downward day by day. Shadows stretch farther across lawns and sidewalks. A baseball field, a beach parking lot, or a cottage road can look softer than it did in June. The warmth is still present, yet the hour carries a small signal that time is moving. Cooler nights may begin returning, depending on the place. A window that stayed open all night in July may need to be lowered before morning. Dew forms more easily on grass when nighttime air cools enough for water vapor to condense. A towel left outside can feel damp at sunrise. Late summer also has a cultural ending. The astronomical season continues until the September equinox, usually around September 22nd or September 23rd in the Northern Hemisphere. That equinox is when day and night are nearly equal in length. But the emotional ending of summer often arrives earlier. School supplies appear in stores. Backpacks and notebooks replace beach towels and pool toys near the front aisles. Camp sessions end. Vacation rentals empty out. Lifeguard schedules change. Families count the final weekends before routines return. The weather may still be warm, but the calendar begins pulling people toward structure. This is why late summer can feel bittersweet, without anything dramatic happening. A person can stand outside on a warm evening and feel both comfort and a faint awareness that the season is narrowing. The pool is still blue. The grill still smells of smoke. The insects are still calling from grass and trees. The day still carries heat, fruit, water, and open air. Yet the long, bright ease of early summer has started to become measured. There are fewer free weekends ahead than behind. Fewer late sunsets waiting. Fewer mornings that belong completely to the season. That limit gives summer some of its value. A season that lasted forever would feel different. The warmth feels precious because it gathers, peaks, and begins to slip away. The long evenings matter because they shorten. The harvest tastes rich because it arrives only after weeks of light, rain, heat, and growth. The answer begins to take shape here. Summer feels good through a brief alignment of forces. The tilted earth, the longer light, the warmed body, the living landscape, the open calendar, and the memories that form while all of them meet. For a short while, ordinary life receives more light than it does through most of the year. That is where the feeling begins. Earth leans on its axis by about 23.4 degrees. During Northern Hemisphere summer, that lean points the northern half of the planet more directly toward the sun. Days grow longer. Sunlight reaches the ground at a higher angle. Fields, lakes, streets, rooftops, forests, gardens, and beaches receive more solar energy across more hours. The season that feels personal begins with planetary geometry. That light enters the body through the eyes. Special cells in the retina respond to brightness and send signals to the suprachiasmatic nucleus, the brain's central timing clock. This small region helps organize the circadian rhythm, the roughly 24-hour cycle that shapes sleep, wakefulness, body temperature, hormones, and alertness. Summer light gives the body a stronger daytime signal. Morning can feel more awake. Evening can feel less closed. The day seems to stretch beyond its usual edges. Warmth adds another layer. Comfortable heat lowers the barrier between the body and the outside world. Fewer layers are needed. Skin can feel air directly. A chair on a porch, a towel on a dock, a path through a park, or an open window becomes easier to enter and stay with. The body welcomes warmth when it remains within a safe range. Sweat, blood flow, shade, water, and rest all help keep that balance. Summer feels best when the body can receive heat without being burdened by it. Water softens the season because it handles heat differently than land. Its specific heat capacity is about 4.18 joules per gram for every 1 degree Celsius of warming, which means water changes temperature slowly. Lakes and oceans store heat more gradually than pavement, sand, and brick. That difference helps create lake breezes and sea breezes, while swimming cools the body through direct contact. A shoreline becomes relief shaped by physics. Summer also reaches the mouth and nose. Watermelon holds about 92% water. Cucumbers hold about 95%. Berries, peaches, tomatoes, corn, and melons carry the work of warm season growth into food. Grills create brown flavors through the Maillard reaction, when amino acids and sugars react under heat. Smoke from wood or charcoal adds aromatic compounds that cling to food and drift through the air. Smell carries the season even deeper. Sunscreen, grass, rain on pavement, lake water, chlorine near a pool, and barbecue smoke are chemical signals moving through air. Smell passes through the olfactory bulb and has close links with the amygdala and hippocampus, brain regions involved in emotion and memory. That is why one scent can return a whole summer place before words arrive for it. The living world adds its own fullness. Plants use photosynthesis to turn carbon dioxide and water into sugars with the help of sunlight, releasing oxygen as a byproduct. Chlorophyll captures light inside leaves. Grass thickens. Trees build shade. Flowers offer nectar. Fruit grows around seeds. Once plants expand, insects and birds gather around them. Crickets call faster in warmer air. Cicadas vibrate their timbrels in the trees. Fireflies make light through bioluminescence. Birds feed chicks when insects are abundant. Heat also builds storms, lifting moist air into tall cumulonimbus clouds until rain, thunder, wind, and cooler air break through the afternoon. Culture completes the pattern. School breaks, summer camps, family trips, long weekends, roadside fruit stands, public pools, beaches, patios, festivals, and late walks all teach people to expect summer as a season of release. Childhood gives that expectation its first deep shape. Memory keeps it vivid because summer often brings novelty, changed routines, and sensory-rich scenes. The season feels good through convergence. Astronomy gives it light. Biology turns light into timing. Weather turns heat into comfort, storms and relief. Ecology fills the world with growth and sound. Culture gives the season permission. Memory gives it a long afterlife. Summer becomes a temporary abundance. Warm air at an open window. Fruit on a table. Insects in the grass. Water holding the last brightness of the day. And a little more time before the dark fully arrives.